This video is the Unit 4 Section 1 EdPuzzle quiz on states of matter and phase changes. So there are three main states of matter. I'll go through them on the next slide. The state or the phase of matter refers to the general physical properties of the different materials and chemicals that we use in the lab. There are three states of matter, as already mentioned, and they are solids, such as solid water or ice, as shown on screen. Now, the properties of ice are that it has a definite shape. The shape is fixed, like it has a defined shape that you can describe in this case as cubes. It has a fixed volume, which means that that solid takes up the same amount of space. And it doesn't flow usually. Usually solids don't move on their own. Liquids, however, like say liquid water, their properties are slightly different. They do not have a defined shape. They fit the shape of the container that they're in. They do have a fixed volume, though. The same amount of water will always take up the same amount of space. And as we would expect, liquids also flow. They move just based on the force of gravity, and if you reorient them, they're going to kind of change shape and flow. Gases are our last state of matter. Gases, which actually on screen, this is representing gaseous water. Although this technically is steam, it's a little bit different. But gases, their properties are that they do not have a defined shape. They basically, again, fill the shape of whatever container or room they're in. They do not have a fixed volume. They basically grow or shrink based on that container that they're in. And they, as liquids, also flow. That's why gases sometimes look like liquids as they're flowing through the air. So when it comes to looking at these states on an atomic or molecular level, solids have this kind of rigid shape, although the atoms technically are vibrating in place. There is movement, it's just not gross movement. It's not massive movement. They're all just vibrating in place. Liquids, they do flow across one another. You can see these particles are kind of flowing around one another. They're not vibrating, they're actually moving. So they're flowing past one another. And with gases, they bounce around their container. They fill the space of whatever container they're in, bouncing around the edges. So, how does temperature affect the phase of matter? Well, as temperature changes, depending on the material, it's going to move between those three main states. Solids usually exist at low temperatures, liquids at medium temperatures, and gases at high temperatures. So, as we have low temperatures, we'll freeze into a solid. As we have high temperatures, we'll see the smoke. Well, not really smoke, but the gas come off of material, usually as bubbles. And remember, solids at low temperatures, they're going to vibrate in place. Liquids at medium temperatures are going to flow, and gases at high temperatures are going to move around their container. Pressure is a slightly different concept, but pressure can also force a material to move between the different states. Solids exist at high pressures, liquids at medium pressures, and gases at low pressures. Essentially, solids, if you squeeze them under a lot of pressure, they're going to adopt this rigid shape. Liquids at medium level pressures, they will be able to flow past one another, but they won't really cling to one another as tightly as in a solid. And at very low pressures, gas molecules or atoms are allowed to expand. They're not being pushed together by a high pressure, so they basically fill the container they're in. Now, if you were to pressurize this gas, as you put more pressure on it, it would become a liquid. And if you increase the pressure further, it would eventually adopt this solid shape. And that is shown in this diagram right here. If you smush this gas, we can see the higher pressure situation on the right, it would eventually become a liquid. And if we smushed it further, it would become a solid. So question number 1, you have a material at very low temperature and a very high pressure. What phase would you expect this to be in? Please answer this on the EdPuzzle. We would expect this to be a solid because solids exist when our temperatures are very low. The atoms or molecules don't have a lot of temperature, a lot of energy to move past one another. And that high pressure is going to squish them into that solid shape. And remember, that's what that solid shape looks like on the atomic level. Question number 2, you have a material at a very high temperature and a very low pressure. What phase would you expect this to be in? So this we would expect a gas. At the high temperature, these atoms have a lot of energy and they can kind of jump around their container really fast. And we have a low pressure, so those molecules are allowed to expand. There's nothing kind of squishing them together in place. Now let's talk about phase changes. So with each of these states, as they move between the different states or phases, we call the transitions a different name. If we say go from a solid to a liquid, just like ice going to water, we say that that solid melts into a liquid. If we go back from a liquid to a solid, say water back to ice, we call that freezing. These are the names we know from everyday life. However, if we go from a liquid to a gas, we call that boiling. The liquid boils into a gas, and if that gas goes back into a liquid, say if the temperature drops, that gas undergoes condensation and it condenses back to a liquid. These transitions from solid to gas on the right here, these are a little more rare in everyday life, but they do occur. If we say go from a solid to a gas, we call that sublimation. You can see that arrow points from solid to gas. A solid sublimes into a gas. And a gas deposits itself back as a solid. We call that deposition. So let's say we heat up a liquid until it begins to bubble and turns into a gas. What do we call that phase transition? We call that phase transition boiling. When we see a liquid bubbling into a gas, that is boiling. How about if we cool down a liquid until it turns back into a solid? What do we call it when a liquid turns back into a solid? That is freezing. When a liquid becomes a solid, just like we can see that water is becoming ice in this time lapse, that is a freezing event. And last question on the phase transitions. Let's say you decrease the pressure on a solid and it's going to turn directly into a gas. The solid is becoming a gas. What is that phase transition? So that phase transition we call sublimation. The solid is going directly into a gas, as we can see here with this piece of dry ice. In the last part of this video, we're going to talk about phase diagrams. So phase diagrams are ways to represent what phase a chemical will be in at different combinations of pressures and temperatures. Now, every phase diagram will look more or less what you see on the right, with temperature on the x-axis increasing as you go towards the right, and pressure on the y-axis increasing as you go up. Basically, every phase diagram consists of three sections. A section on the left where the solid phase of the material exists, a section in the center where the liquid phase of the material exists, and a section on the right side where the gaseous phase of the material exists. You're going to see that this corresponds to solids being at low temperatures and usually higher pressures. The liquids being at middling temperatures and mostly higher pressures, but some lower pressures as well, and the gaseous phase being at high temperatures and lower pressures. So for instance, if we want to find out what phase a material will be, one example is over here on the left. We'll see the temperature says 120 degrees Celsius and the pressure is 3 atmospheres. To figure out what phase this is in, we'll go over to 120 on the temperature side, up to 3 atmospheres on the atmosphere side, and where these two lines intersect is right here. So we can see this would be in the liquid phase of the diagram. So a question for you, what phase will this chemical be in at a temperature of 30 degrees Celsius and a pressure of 3.5 atmospheres? If we use our diagram here, we can see that a temperature of 30 degrees Celsius on the x-axis and 3.5 atmospheres on the y-axis puts us right here. You'll see a blue star will overlay that. We can see this is the solid phase as compared to the liquid or gas phase. So right there, the solid, where you see that blue star, this is obviously a solid. Next question, what phase will this chemical be in at a temperature of 220 degrees Celsius and a pressure of 1 atmosphere? Again, if we highlight 220 Celsius on the x-axis and 1 atmosphere on the y-axis, we can see that this will be in the gas phase where that blue star is. So this is a gas. One more of these questions. What phase will this chemical be in at a temperature of 170 degrees Celsius and a pressure of 2.5 atmospheres? If we head over to 170 Celsius and 2.5 atmospheres, and I'll label my diagram with solid, liquid, and gas, we can see that these two temperature and pressures intersect right there in the gas phase. We can also use phase diagrams to see what transition will happen, what kind of phase change will occur. Basically, if we go from one state to another, we should see a transition from one area of the graph to another across one of these phase lines. As an example, let's say a chemical starts at 30 Celsius and 3.5 atmospheres, and it ends at 130 Celsius and 3.5 atmospheres. I can see my material will start at 30 Celsius and 3.5 atmospheres. So it's almost like right here is my starting point. And my ending point is at 130 Celsius and 3.5 atmospheres, right around here. In this case, I can see this is going from the solid phase to the liquid phase. As we talked about on an earlier slide, when a solid transitions into a liquid, this is melting. One more quick example. Let's say a chemical started at 160 degrees Celsius and 3 atmospheres right here, and it went down to 160 Celsius, so the temperature stayed the same, but it decreased to 1 atmosphere right down here. We can see that this transition would be liquid transitioning into gas, and because it's going from liquid to gas, we said that was boiling. All right, now your time to turn to try. What phase transition would occur if this chemical starts at 100 Celsius and 3.5 atmospheres of pressure, and it ended at 10 degrees Celsius and 3.5 atmospheres of pressure? Go ahead and answer on your screens. We can see that if we label these different phases and we draw that arrow, this is a liquid to solid transition. It is occurring right here, starting here and ending here. And a liquid to solid transition, we said before, was freezing. On the next slide, what phase transition would occur if this chemical started at 220 degrees Celsius and a pressure of 1.5 atmospheres, and it ended at 320 degrees Celsius and a pressure of 1.5 atmospheres? Go ahead and answer on your screens. If I label my different sections, I can see that this chemical is going from the solid to the gas phase. It's starting here, ending here. And we said that a solid to gas phase transition was sublimation. And that is the Unit 4, Section 1 EdPuzzle on states of matter and phase changes.